In just 3 short days, the universe unleashed a sequence so rare and improbable that scientists are still struggling to fully process it. Between September 23rd and September 25th, 2025, 4 extraordinary events unfolded almost back-to-back. 2 distant stars suddenly erupted into novas, growing bright enough to be seen with the naked eye. At the very same time, the Earth itself shook violently as twin magnitude 6 earthquakes tore through Venezuela within hours of each other. And as if that wasn't enough, the Sun hurled a massive coronal mass ejection directly into the path of the only confirmed interstellar comet currently in our skies. 3IATLAS researchers have given this compressed timeline a name: the 72-hour event stack. It represents not just a collection of natural disasters and cosmic outbursts, but a convergence that almost defies probability. Normally, we might see a naked-eye nova once a year, or sometimes not at all. Major earthquakes of this scale in the same region are expected only once every few years. And an interstellar object like 3IATLAS being struck by a solar storm? That's the kind of event you might expect once in a generation, if ever. Yet all of these aligned within the span of 3 days. The odds are staggering. Statisticians estimate the probability of this happening at less than 1 in 1,000, perhaps even rarer, depending on how the math is run. This is why experts are calling it a statistical outlier of the highest order. It's not just what happened, but how perfectly the pieces overlapped, as though the cosmos, the Earth, and the Sun were all conspiring to remind us of just how little control we really have. Among the most striking elements of this 72-hour window were not 1, but 2 stellar explosions, novas, that lit up the sky. Normally, if humanity is lucky, we witness a nova bright enough to reach the threshold of naked-eye visibility once in an entire year. Sometimes years go by without a single one. Yet in September of 2025, 2 separate stars erupted within just 48 hours of each other. The first, known as V1935 Centauri, flared to life in the early hours of September 23rd. This wasn't a new star being born, but rather the violent outburst of a white dwarf star locked in a binary system. As it slowly siphoned hydrogen from its companion star, the material built up on the white dwarf's surface until it triggered runaway nuclear fusion. In a matter of hours, its light output surged 100,000 times over, bright enough for backyard stargazers to see from dark skies without any telescope at all. For many, it was the kind of once-in-a-lifetime sight astronomers dream of, but the cosmos wasn't done. Less than 2 days later, another star, V799994 Sagittari, followed suit. It too reached magnitude 6, the threshold of human visibility. Astronomers worldwide scrambled to confirm the eruption, while high-energy satellites detected bursts of gamma rays and X-rays, clear evidence of shock waves and particle acceleration unleashed by the blast. What makes this pairing so extraordinary is not just their timing, but their intensity. These were not subtle flickers. They were explosive thermonuclear events, visible across light-years of space. For 2 such novas to erupt back-to-back, both visible to the naked eye, is statistically almost impossible. The odds of this happening within just 3 days are less than 0.002%. For observers on Earth, it was as if the universe had ripped open a curtain, offering a fleeting glimpse of stellar violence on a scale almost too immense to imagine. As if the sky wasn't already delivering shocks, the Earth itself joined the chain of extraordinary events. On the evening of September 24th, Venezuela was shaken by a powerful magnitude 6.2 earthquake near Mene Grande. Shallow, at less than 8 kilometers deep, it sent violent waves racing directly to the surface. Homes trembled, power lines swung wildly, and families fled into the streets just as dinner time ended. Hospitals, already under strain, scrambled to handle a sudden surge of injuries. Medical staff rushed patients into parking lots, and improvised triage areas under the open sky, bracing for what might come next. But the ground wasn't done moving. Less than 6 hours later, in the early hours of September 25th, a second quake struck the same region. This time a magnitude 6.3 at a slightly deeper depth of 14 kilometers. Buildings already cracked by the first tremor took further damage. Aftershocks rolled in, one as strong as magnitude 5.8, forcing exhausted doctors and nurses to evacuate patients yet again. For locals, the night was defined by fear and improvisation. Families huddled outside while radio stations and WhatsApp groups relayed urgent updates, turning community networks into lifelines. Seismologists later explained that this wasn't random chaos, but the stress of tectonic plates transferring energy from one fault line segment to another. A classic pattern, but no less terrifying for those living through it. To have two earthquakes of this size in the same region, in such a short window, is already extremely rare, about 1 chance in 10,000. That it happened in the same 3-day span as novas and a solar eruption targeting an interstellar comet makes the timing feel almost unreal. For those on the ground, it wasn't a matter of statistics. It was survival. In the middle of a week, when even the Earth seemed to be caught up in the cosmic storm. While Earth and distant stars were making headlines, the Sun delivered its own dramatic contribution to the 72-hour event stack. At the height of its activity cycle, our star unleashed a massive coronal mass ejection, a vast cloud of charged plasma hurtling through the solar system at millions of kilometers per hour. These eruptions are common during solar maximum, but this one had an extraordinary target in its sights. 3IATLAS, the only confirmed interstellar comet currently passing through our neighborhood. For the first time in history, scientists witnessed a CME striking not a local comet born in the Oort cloud or Kuiper belt, but a traveler from another star system entirely. 3IATLAS, racing along a steep retrograde orbit at over 60 kilometers per second, found itself directly in the path of the Sun's fury. Models suggest the plasma wave and the comet's coma overlapped within an 8-hour window on September 25th, transforming this cosmic visitor into a living probe of solar physics. The significance of this can't be overstated. When CMEs slam into ordinary comets, they often trigger dramatic outbursts, tails snapping, glowing plasma sheets, even temporary disconnections. But with 3IATLAS, researchers are getting a once-in-a-generation opportunity to watch how truly alien material reacts under solar assault. Every particle streaming from its nucleus carries chemical fingerprints from another star system, older than our Sun. Exposing that material to the violence of solar plasma may reveal secrets about both its origins and the nature of interstellar dust. For heliophysicists, this was more than a coincidence. It was a natural experiment they could never have planned. And for astronomers worldwide, it marked a milestone. The first time we've seen an interstellar visitor directly struck by the power of our own star. When scientists began lining up the timelines of these events, 2 naked-eye novas, twin Venezuelan earthquakes, and a direct CME striking an interstellar comet, something immediately stood out: the odds. Each one of these events is already rare on its own. Naked-eye novas, for example, usually occur only once or twice a decade. 2 happening within just 48 hours? That's already extraordinary. Large earthquakes often cluster, but for 2 magnitude 6+ tremors to strike the same Venezuelan region in under 6 hours is an extremely rare seismic doublet. And then there's the CME, hitting 3IATLAS dead on. The first such impact on an interstellar object ever observed. Statisticians working with astronomers have tried to model this overlap. The math suggests that the combined probability of all these phenomena stacking within the same 72-hour window is less than 1 in 1,000. In other words, even if you tracked cosmic and terrestrial events for centuries, you might never expect to see this exact sequence again. That's why researchers have begun referring to it as an event stack, a cluster of anomalies so tightly packed that they seem to defy randomness. But numbers only tell part of the story. For those watching in real time, the effect was visceral. Every few hours, something else happened. An explosion in the sky, the ground shaking, the sun blasting plasma into deep space. It felt less like chance and more like a drumbeat, as if the universe itself was sending signals in rapid succession. Of course, scientists are cautious. Coincidences do happen, and nature has its own rhythms. Yet the timing is so tight, so unlikely, that even seasoned researchers admit it carries an eerie weight. Whether you call it coincidence, synchronicity, or cosmic choreography, the 72-hour event stack stands out as a statistical outlier, a once-in-a-lifetime convergence of sky, Earth, and Sun. Beyond the headlines and the shock factor, the 72-hour event stack delivered a scientific treasure trove. Each event, by itself, would have been worthy of intense study. But happening in such close succession, they offered researchers an interconnected dataset, unlike anything seen before. The twin novas, V1935 Centauri and V7994 Sagittari, weren't just bright spectacles in the night sky. They produced intense bursts of gamma rays and X-rays, signatures of nuclear fusion runaway reactions. Space-based observatories like Fermi and Swift detected the high-energy flares almost instantly, allowing astronomers to track the physics of stellar explosions in real time. These measurements give rare insight into how white dwarfs accumulate matter from companion stars until they ignite, and they provide critical clues to the chemical enrichment of our galaxy. Meanwhile, the Sun's coronal mass ejection slamming into 3IATLAS has opened a completely different window of investigation. No human mission could ever orchestrate such an experiment, yet nature delivered it freely. The CME's high-energy particles are now interacting with dust and ices that formed around another star system, perhaps billions of years ago. Instruments on Earth and in orbit are detecting unusual ionization patterns in the comet's coma, data that may tell us how alien material holds up under solar assault. This could reshape our understanding of interstellar dust, volatile chemistry, and even the survivability of organic compounds as they travel between stars. Together, these cosmic and solar events compress years' worth of potential discoveries into just 3 days of observation. For scientists, it was overwhelming but thrilling, an accidental gift from the universe that may yield insights for decades to come. When the earthquakes struck Venezuela during the event stack, the human toll was immediate. Buildings swayed, walls cracked, and thousands poured into the streets. But for doctors, nurses, and first responders, there was no pause to process the fear. They had to act instantly. Hospitals in Zulia and Falcon states, already operating under strained budgets and equipment shortages, suddenly faced a flood of patients. Dozens arrived with fractures, head injuries, and trauma from collapsing structures, while others suffered heart attacks triggered by the shock itself. Inside medical centers, lights flickered and ceilings trembled with each aftershock. Fearing a catastrophic collapse, staff rushed patients outside into parking lots, schoolyards, and even church courtyards. Makeshift wards appeared under open skies, where IV bags dangled from trees and stretchers were lined up under tarps. With power cuts rolling through the region, ventilators and monitors ran on dwindling generator fuel. Doctors fell back on paper charts, flashlights, and whatever supplies could be salvaged. What kept the system functioning wasn't technology, but community. Volunteers delivered bottled water, blankets, and painkillers from local pharmacies. Amateur radio operators and WhatsApp groups became lifelines, spreading urgent information about safe zones, road closures, and aftershock warnings. In some cases, residents with cars transported the injured themselves when ambulances couldn't reach collapsed roads. For many Venezuelans, The earthquake response revealed a painful truth. The official system was stretched to the breaking point, yet it also showed resilience. In the middle of chaos, ordinary people and exhausted medical staff created order from nothing, proving that survival in disaster often depends less on infrastructure and more on human solidarity. At the center of this entire cosmic drama is 3I-ATLAS, only the third confirmed interstellar object to enter our solar system after Oumuamua in 2017 and Borisov in 2019. Unlike ordinary comets bound to the Sun, 3I-ATLAS is a true outsider. A traveler from another star system cutting across our neighborhood on a steep retrograde orbit. That means it's moving against the general direction of the planets, plowing head-on into the flow of the solar system at breakneck speed. Its path has already brought it close enough to raise eyebrows in the planetary science community. On October 3rd, it will pass within just 0.19 astronomical units of Mars, less than 30 million kilometers. That may sound vast, but in cosmic terms, it's a near miss, close enough that the red planet's orbiting spacecraft will get a front-row seat. Cameras aboard NASA's MAVEN and Europe's ExoMars orbiter are being tasked to watch, hoping to capture both the comet's coma and its interaction with the Martian atmosphere from afar. The real milestone, however, comes on October 29th, when 3I-ATLAS reaches perihelion, its closest approach to the Sun. At that point, it will skim inside Earth's orbit, its icy surface bombarded by intense solar radiation. If it survives, astronomers expect the comet to brighten dramatically, potentially becoming visible with binoculars or even the naked eye. But if it fragments, as many suspect after the CME impact, its breakup could reveal pristine material from another solar system, exposed to us for the first time in history. For scientists, the trajectory of 3I-ATLAS isn't just a line plotted on a chart. It's a one-time chance to study interstellar chemistry and dynamics up close. For the rest of us, it's a reminder that the solar system is not isolated. Visitors do come, carrying with them stories older than the Sun itself. For skywatchers, the next few months will be nothing short of historic. After the shock of the September event stack, the calendar ahead is filled with opportunities to see some of these cosmic players with your own eyes. The first date to mark is October 20th and 21st, when Comet Swan makes its close approach to Earth. At its brightest, astronomers expect it could be visible through binoculars under dark skies, glowing as a pale green fuzzball in the constellation of Leo before dawn. For casual stargazers, it's a chance to witness a comet with no telescope required. Just days later comes the real centerpiece, October 29th, when interstellar comet 3I-ATLAS reaches perihelion. At this point, the comet will be at its closest distance to the Sun, where solar heating should drive spectacular outgassing. If it holds together, its tail may stretch across large swaths of the night sky, potentially making it one of the brightest cometary displays in years. Professional observatories from Chile to Hawaii will be tracking it, but amateur astronomers worldwide are being encouraged to share images as well, turning the event into a truly global watch party. Finally, December 19th brings another milestone, 3I-ATLAS's closest approach to Earth. At a distance of about 0.278 AU, or 40 million kilometers, it will not pose any danger, but it may still shine as a prominent object in backyard telescopes. By then, scientists will know whether it has survived intact or fragmented into multiple pieces. Either way, the spectacle should be unforgettable. In just 3 months, the night sky will stage a series of cosmic performances. One comet from our own solar system, and one interstellar traveler passing through for the first and only time in human history. For anyone who has ever wanted to witness astronomy in real time, this is the season to look up. One of the most exciting aspects of the 3I-ATLAS saga is the role of amateur astronomers and citizen scientists. Professional observatories are stretched thin, tracking multiple events and collecting high-resolution data. But they can't monitor every detail across the globe. That's where the community comes in. Anyone with binoculars, a telescope, or even a good quality camera can contribute to understanding this once-in-a-lifetime visitor. Observers are encouraged to carefully track changes in the comet's brightness, note sudden surges, monitor the development or kinks in its tail, and look for any unusual disconnections caused by solar-wind interactions. Every sketch, photograph, or magnitude estimate logged with databases like the AAVSO, the International Comet Quarterly, or the Comet Observation Database adds a piece to the puzzle. Even small observations, when aggregated, help scientists distinguish real physical phenomena from observational noise. Responsible reporting is key. Precise timestamps, location data, and details about the equipment used can make amateur contributions scientifically valuable. Sharing observations in real time allows researchers to react quickly if 3IATLAS behaves unexpectedly, such as fragmenting or undergoing sudden brightening after perihelion. In essence, every skywatcher becomes part of a global research network, transforming curiosity into data and participation into discovery. This collaborative approach ensures that while coincidences and rare events may initially appear random, the combined efforts of professionals and amateurs can reveal patterns and connections that no single observer could capture alone. It's a reminder that astronomy is not just about looking up. It's about working together to decode the stories written across the sky.